Hi friends, this video is going to be about slope. And so you might be asking yourself, well, haven't we been talking about ratios in this unit? And isn't this unit all about comparing two different values and finding a rate? And I would say, yes, that's exactly what we are doing. And a slope is a way of describing a rate of change of a line. So you might have noticed, right? I could draw lines that are steeper or lines that are shallower. So, for example, you can see this blue line here, but I could draw a line uh, like this, right? That's maybe I might say it's not as steep, but it wouldn't be as hard of a hill to walk up if I thought of it that way. Or I could draw a line maybe like this, right? Really very shallow line. Or maybe my line's not going up at all as I go from left to right. Maybe I've got a line that's going down as I go from left to right. Okay? And for all of these lines, the way that I can describe where that line is going and how steep that line is, or how shallow that line is, or how that line is changing, right, as it goes in one direction or another, the way that I can do that is to talk about the slope. And the slope is a ratio that compares two things, two values. So let me get rid of some of these extra lines here. Okay, so here's what we're comparing. We're comparing the steepness, how far up the line goes for every step over that we take. So we're comparing what we call the rise, right? And remember, this is our y-axis. So the rise rises on the y's. It's hard to say, but it makes it a little easier to remember. So the rise is how the y is changing, right? So we're going up. So notice here, if I take a look at this line, it's going to go up this far, and then it's going to go over from this place to the other dot. So the way to go over is to run, right? We're going to run over. We're going to rise with the y's and run with the x's. Okay. So for any 2 points on a line, I can draw this sort of slope triangle, and I can use it to find, well, how much rise did I have? Well, I came up here 1 step, 2 step. And when I'm counting from the point to the next sort of mark. So 1 step, 2 steps. So that's going up, so it's going +2. And then from here, right from the corner, I'm going to the right. And remember that this is a positive direction on the right side and a negatives on the left side. So I'm going to the right one, which is +1. So my rise for my slope, and slope is written with the letter M as the symbol for it. So I'm going to figure out my change in y. You might have seen this symbol in science, delta y. It means change in y divided by change in x, or rise over run. And so my slope here is equal to 2, because I went up 2, +2, over +1. So my slope is 2 over 1. Let's take a look at another example. So here's a different line, right? It's, I don't know, if I look back at it, it's kind of similar. Let's see what this rise and this run is. So again, so the rise, oops, let's undo that. The rise is going to be how high up I go, right? So we're going to draw our triangle from here up just to the same level. And then the run is how far over I'm going to go. So from that corner, I'm going to come over. And so now I'm just going to count. 1, 2, 3, 4. So it goes up 4. Again, remember, positive, negative, positive, negative. So up 4, and then it's going to go over 1, 2, so over 2. So my slope is equal to 4 over 2. Well, hey, 4 over 2, I can simplify that ratio, so that slope is equal to 2 over 1. In fact, this is kind of neat. If you take a look, this line, see here how this one's not at an intersection, but this point right here is another point on the intersection. And so I could have counted from here up 2 over 1, up 2 over 1. Or I could count up 4 over 2. What if I counted up 6? 1, 2, 3, 4, 5, 6. How many over do you think I'm going to count? 1, 2, 3. Up 6 over 3. Interesting. So remember when we were talking about equivalent ratios, right? This slope is the same, the slope of 4 over 2 is the same as the slope 2 over 1 because they're equivalent ratios. So remember when I looked at this line and I was like, I don't know if this one looks steeper or less steep. It turns out they're the exact same steepness. This one just happens to go through, the whole thing is shifted up a little bit. And here it goes through at a lower point, right? But it's the same steepness. It would be just as hard to walk up these stairs as it would be to walk up those other stairs. Let's take a look at some other examples. Okay. So here when I go to my next point, instead of rising up, I'm gonna rise down. So look here, in order to get from here to here, my y is gonna go down some spaces. And then my x is still gonna go over here in the positive direction. So I'm going down and then positive direction. So I'm going to count this out. 1, 2, 3. So I just went down 3, so we're going to call that -3. So my rise here is -3, go down 3. And then my run is 1, 2, 3, 4, 5, 6, +6. So when I write my slope is the rise over the runs. And I might notice there that 3 and 6 I can simplify, so that's going to be -1 over 2. Notice this line is negative because when I read it from left to right, it's going down. It's a downhill slope, so it's a negative slope. Cool, let's take a look at this one over here. So I'm going to count down again. This is another -1. Hang on, I'm just going to fix that color. So I'm going to go down, and it looks like I'm going to go down 1, 2, and then I'm going to go 1, 2, 3, 4, 5 over to get to the other dot. So again, I went down, so it was -2, and then over +5. So my slope is -2 over +5, and that one cannot be simplified. So if we're given a picture of a line, the easiest way, the most straightforward way for us to find the slope and to write out what is the ratio of how much it's going up or down for every step that we go over is to write our fraction or our ratio with the rise over the run. Okay, so let's do a little bit of practice on that. I hope this video helped make some sense of that.